Type 5, factoring in quadratic form, ax squared plus bx plus c. That's what quadratic form looks like. While I'm going through this, you should have this open. Factoring in quadratic form. We're going to do 1, 2, and 1 again. All right? But after I do 1, you should see if you can do the rest of them by yourself. Hopefully you can. But we're going to do all 3 together. So if you get stuck on 1, you can come and check it out. And look, I even gave you a hint. Get it equal to 0 first. That sure is right. That's what we're going to do first. So we've got this equation. Now remember, I said first you need to ask yourself, can you combine like terms so that you have just one term with a trig expression? Now we've got cosine squared and 2 cosine x. They are both cosine, but since this one's squared, we cannot combine them. They are not alike. They're too different to be living under the same roof. They can't be combined. All right? So instead, what it looks like is that we've got 2 terms with the same trig expression but different exponents. When that happens, here's our steps. We're going to get it equal to 0. Right now it's not equal to 0. So there's step 1. Get it equal to 0. Minus 3. So I've got cosine squared x plus 2 cosine x minus 3, and now it's equal to 0. Now I'm going to check for a GCF. That means that they've all got to have something in common. Well, these 2 have a cosine in common, but negative 3 does not have a cosine. And there's no number that is both divisible by 1, 2, and negative 3 except for 1, and nobody wants to factor out 1. That's too boring. So instead, we're going to factor it the good old-fashioned way, right? When we've got ax squared plus bx plus c, we got to find 2 numbers that multiply to be negative 3 and add to be 2, right? And make sure that you've written this in standard form. Standard form goes from highest exponent to lowest exponent. So we've got squared to the first power to the 0th power, right? Because anything to the 0th power is 1. So if we had cosine x to the 0th power, it would just be 1, right? So we've got 2, 1, 0. So it's in standard form. Make sure you've written it in standard form. So 2 numbers that multiply to be negative 3. The only numbers that multiply to be 3, period, are 3 and 1. Since it's got to multiply to be negative, one of them has to be negative, one of them has to be positive. We have to add to be a positive number. So my bigger number needs to be positive, because that's the rules of adding positive and negative numbers, that the bigger number is what sign you keep. So I'm going to have 3 minus 1. 3 times negative 1 is negative 3. 3 minus 1 is 2. So here's how I factor this. I'm going to have cosine of x instead of just plain old x plus 3 and cosine of x minus 1 equals 0. Let's check that and see if it's right. Cosine, if I were to redistribute, right? Cosine times cosine is cosine squared. Cosine times negative 1 is negative cosine. 3 times cosine is 3 cosine. So 3 cosine minus 1 cosine will give us positive 2 cosine. And 3 times negative 1 is negative 3. All right? So it worked. Now remember when we were taking the GCF, once we've got our 2 factors that multiply, right, this is multiplication to be 0, then we can set each factor equal to 0. Okay? So over here, I've got cosine of x plus 3 is equal to 0, and over here, I've got cosine of x minus 1 is equal to 0. Solve. Cosine of x is going to be equal to negative 3, and over here, cosine of x is equal to 1. Okay, so now we've got to figure out what x is. What angle will give us negative 3, and what angle will give us positive 1. So let's tackle this one first. Cosine equal to negative 3. Some of you might already be thinking that looks really fishy because some of you really enjoyed graphing last semester. I know, it's really all of you. And you remember that the cosine graph oscillated, right? Between positive 1 and negative 1. It never went beyond positive 1 and negative 1. So it is impossible for cosine to be equal to anything beyond positive 1 or beyond negative 1. And negative 3 is beyond negative 1. It's farther than negative 1. So we're going to have that this is not possible. And sometimes that happens, and it's okay. It's not possible. So this one gives us no solution. It's invalid. There's no x value that I could plug in here that would give me negative 3. okay? And if you don't believe me, which you should, you can also plug this in on your calculator. I want you to go type in cosine inverse of -3. Now I'm kind of jumping the gun because our calculator section isn't for a little while, but if you type cosine inverse of -3 on your calculator, you're going to get math error, which also tells you that it's not possible, okay? Not possible. Over here, cosine of x is equal to +1. That happens, remember, cosine is on our x-axis, +1 is here, so 0. X is equal to 0. Okay, now I didn't write it, but this one had restrictions that x is between 0 and 2 pi. Okay, so we can be equal to 0, that's good. And then we also have a solution at 2 pi, right? But we cannot be equal to 2 pi. We are strictly less than 2 pi. So 2 pi is not actually a solution, just 0. That's our only solution. I know that you're really satisfied getting 0 as an answer. You love it. All right, go try the other ones. I'm gonna make another video for the 2 different types, the 2 different other problems that are remaining. Try them yourself, struggle through them, then watch the video, see if it's correct. All right?